Hello ladies and gentlemen, and thank you for listening to another video of Mr. Laxton talking through these Algebra II 10.5 notes. Today we're talking about hyperbolas, alright, and this is the last different type of conic that we have to talk about, and then we have covered them all. So a hyperbola is a different looking shape than we've talked about, but that's what we're going to look at today. So my essential question here today is, what is a hyperbola, and how do I graph them? All right, so just to kind of skip down here, hyperbola is sort of there's two different types. That's the main gist for the first here. There's two different types. There's a horizontal type and there is a vertical type. And the difference in the equation is that a horizontal, the x squared comes first, and in a vertical, the y squared comes first. All right. And the difference in the graphs is, as you guys can see here, the horizontal, when the x squared comes first, this guy opens in the right and in the left. Okay, it's kind of like two parabolas-ish. All right, they're kind of two parabola-looking figures. Excuse me. And then the vertical one is they open up and down. Okay, and that's going to be the main gist here, is that you need to know when your hyperbola opens up and down or when it opens left and right. And that's the kind of two different types. All right, so a couple characteristics here, as you guys can see here. The equation, notice how your x squared is first, so this is horizontal. It opens up in the left and on the right. And then here, if the y squared comes first as vertical, it is up and down. Okay, so as you can see here, again, your vertices are plus or minus your a comma 0, and then your foci are, again, they're inside those parabola-looking shapes. All right, and that's why we have some focus and the foci and things like that down there. Okay, but this equation for the foci is a little bit different. So notice here that my equation for my foci, and this kind of got cut off, so make sure you guys write this in here. C squared equals a squared plus b squared. So notice here, if it's a minus in the original equation, the c squared equation has a plus. All right, so make sure you know the difference there to find your c squared. It's got a plus in between that a squared and b squared instead of a minus. All right, awesome. So as we go on to some concrete examples here, let's take a look. It says rewrite the following hyperbola equations in standard form. So here we go. If I rewrite this guy in standard form, I have to have my x squared and my y squared on the same side, and there has to be 1 on the right side, right? So as I notice here, I have to divide everything by this 81 to make 1 on that right side. So I divide by 81. So now here I have y squared over 81 minus, notice here how this 81 and the 81 cancel out, so I'm going to say x squared over 1 is equal to 1. And this is my standard form equation for this guy. So now we're going to do some things in the next couple examples about, hey, how do I actually graph that? What are my vertices? What are my foci? And so on. All right, awesome. So here we go. The second one, you got to get this 9 over the other side. So I got a minus 9. I got a minus 9. Oh, excuse me. And I want to change this 9. I want to change that 9 to 576. All right, that 9 didn't work out very well there. So I'm going to change that to 576. Awesome, awesome, awesome. And so this is 576. So I'm going to erase these guys. So I'm going to subtract, this is going to be a minus 576, so I'm going to add it to the other side, 576. Sorry about that confusion there. So I'm going to add that 576. So now I have 16y squared minus 36x squared is equal to 576. Now I have to divide by that 576, divide by the 576. And the way that this works, and the way that is pretty nice, is that these guys actually multiplied together make that 576. So that's usually how that works. So now I have y squared over 36, because 16 over 576 turns into 1 over 36, minus x squared over 16 is equal to 1. And that is my standard form equation. Awesome. So here we go. As I look on to example number 3, it asks me to find some different things. So I'm not just writing it in the standard form. I have to find, hey, what are my foci? What are my vertices of this guy? Okay, so let's just go here. My vertices equal, and my foci equal. All right, so we're going to find out what these guys actually are. So here we go. To start out with this one, I got to get it in standard form, so I have to divide by 100. I have to divide by 100. So now I have y squared over 5. Excuse me, 4, Mr. Laxton. 25 goes into 100 4 times. And erase, erase, erase. Y squared over 4 minus x squared over 25 is equal to 1. Okay, so notice here that, hey, this is my standard form equation. And notice, and this is what we have to kind of talk about here, is that my y squared comes first, so that means that this hyperbola opens up and down. Okay, and that's going to be a key thing, because that's going to tell me which way these guys go. So notice here that my a is going to be, so my a squared is 4, so that means my a is equal to 2. All right, so that means that, hey, this point right here and this point right here are both 0 plus or minus 2, okay, because that goes with my a. All right, and my b is 5, so my b squared equals 25, so that means my b is 5. So now I have to go through and actually solve for what my c is to find out what my foci are. All right, so I know that my c squared is equal to my a squared plus b squared. And I know that my a squared is 4 and my b squared is 25, so my c squared is equal to 29. I got to square root both sides, and my c is equal to the square root of 29. And now my foci are going to be up here and down here, so now I know that this is in the same form. It's 0 plus or minus the square root of 29. All right, so those right there are my answers. All right, so those are my foci and my vertices. All right, perfect. So now, steps to graphing. These guys are great here. You got all kinds of good step-by-step here for you. I'm just going to kind of go through this example and talk through how to do it here. So first, we have to get it in standard form. So I got to divide by 144. I got to divide by 144, and I got to divide by 144. All right, and I know that 9 goes into 144 16 times, so it's x squared over 16 minus y squared over 9, because 16 goes into 144 9 times then, is equal to 1. And now this x squared being first, that tells me that this is horizontal. Horizontal. All right, and now I have to find out, hey, my a squared is 16, so my a is 4. My b squared is 9, so my b is 3. And here is how you do this, okay? You always walk what's underneath. So my 4 is underneath my x, so I walk that in the x. So I walk 4 left and right in my x, and then I walk 3, that's underneath my y, that's up and down, okay? So here's how we're going to do. We're going to go 4 right, put a dot there. We're going to go 4 left, put a dot there. We're going to go 3 up, put a dot there, 3 down, put a dot there. Okay, awesome. So now here's really how we do this. We make a rectangle. Okay, so we have a rectangle that goes through these points. Notice how that rectangle goes left and right 4, and it goes up 3 and down 3. Okay, so then now we connect the diagonals here. So we connect the diagonals. I kind of like to do it with a dash line. We connect those diagonals with a dash line or any kind of line. It's fine. And so now I got to come through here. Here's my other diagonal to go through there. And that's going to help us determine how wide or how narrow my actual U shapes are in here. Okay, my hyperbola is. So this guy actually, it's horizontal. Remember we said it's horizontal because my x squared comes first. So this guy comes in really close to those orange right there, goes through that vertice, and oh, it should not go past. So that's my bad. I'm going to erase that guy there. So now this guy should not go past that. So it should go here, go through there, and get really, really close, but not go past. Over here, it should get really, really close, go through that vertice, and get really, really close. So those dashed lines are my asymptotes, all right, that hyperbola gets really, really close to, but doesn't go past. Okay, so what we did there is we made this rectangle. Okay, so make the rectangle and then make sure you connect those guys, and that tells you how wide or how narrow your hyperbola is. All right, so we'll do a bunch of examples of those graphing hyperbolas, I promise. And the next one is writing an equation for hyperbola that's centered at the origin. Okay, so this one gives us some different information, and we got to use that information to determine, hey, does this hyperbola open left and right? Is it up and down? So let's do this. And the way that I like to do is actually sketch out a graph of what we have. Okay, see, it's hard to do this without a graph. So it says an equation for a hyperbola with vertices of 0, 8. So remember, that's my A is my vertices, and it has a foci of 0, 9, and -9. And remember, that's my C. Okay, so I have my A and my C, and let's just go through and graph these guys. So my vertices are 0 plus or minus 8. So let's say that's 0, positive 8. This is 0, negative 8. And my foci are 0, 9 and 0, negative 9. So notice here how this guy has to, remember how those foci have to be inside them, so this guy has to open up and down. Okay? So that tells me something right there. That tells me that this is a vertical hyperbola. So now I know that my y squared has to come first over my a squared minus my x squared over my b squared is equal to 1. Okay, but here's the thing. I don't know what my b is. But I do know what my a and I know what my c are. So I can use this equation, c squared equals a squared plus b squared, to solve them for what my b is. So now I know that this is, hey, 81. This is 64 plus my b squared, because my a is 8, so 8 squared equals 64, and 9 squared equals 81. That's how we get those. All right, so now I just subtract 64, subtract 64. So now I know that, hey, 81 minus 64 is 17, is equal to my b squared. Ooh, that's kind of weird. Now I got to square root both sides, so the square root of 17 is equal to my b. All right, so now when I plug it in here, I actually have to square it, so that's kind of the nice thing about this, is that now I have my y squared over my a squared, which is 8 squared, which is 64, minus x squared over my b squared, which we just found here. My b is this, so my b squared is just 17, is equal to 1. Okay, so that one's a little bit trickier. You got to take the information that you're given, determine, hey, is it horizontal or is it vertical? What does your equation look like? And go on from there. So again, thank you for listening to another video of Mr. Laxton talking through these. I promise we'll do a lot more examples. Please come find me if you have any questions, and have a good rest of your morning, evening, or night, whenever you listen to this.